Hi, sixth graders. This is Mrs. Gall. Today we're going to talk about the difference between proportional and non-proportional relationships. Grab your math notebook, open up to a fresh page, and put this title at the top. Press pause if you need time. Play when you're ready to go. All right, let's get started. So the first two vocab words we have should look familiar because they're part of your title. So proportional relationships are when two quantities have a constant rate or ratio. We're going to look at how we can determine if it's constant in just a second. Go ahead and pause if you need more time to write. Remember that constant means staying the same. So we're going to be looking at how we can monitor or look for that in a pair of numbers. The other type of relationship we're going to see are non-proportional relationships. These are quantities that do not have a constant rate or ratio. So they do not stay the same. Pause if you need more time to write those definitions down. Press play when you're ready to go. Okay, so here we're going to look at number of laps completed by Tom and Jenna for the time that was given up above. So let's write a ratio comparing Tom's number of laps to the amount of time it took him to complete those laps. For example, he completed 3 laps in 5 minutes, so that would be 3 over 5. 6 laps he completed in 10 minutes, so 6 over 10. 9 laps were completed in 15 minutes, 9 over 15, and then 12 laps were completed in 20 minutes. What do you notice about those different rates that we've set up for Tom? Take a second and think about what you're noticing from one rate to the next. So with Tom's laps compared to time, we see that we have a constant rate. How do we know that? All of these fractions can simplify back down to our 3/5. Because look, to get from 3/5 up to 6/10, we just multiplied both of those by 2. So if we divide those both by 2, we get back down to 3/5. Well, what about 9/15? Can we get back down to 3/5 with 9/15? Sure, we can divide both of those by 3 to get down to 3/5. What about 12/20? Can we get 12/20 back down to 3/5? Yes, we can divide them both by 4. So that means that Tom's laps compared to time, it's staying a constant rate. They're all being able to simplify back down to that starting rate, which was 3/5. You could also start at 3/5 and create any of those rates by multiplying the top and bottom number by the same thing. Now let's look at Jenna's rates. Let's write a ratio comparing Jenna's laps to the amount of time. So laps first and then time. So Jenna completed 4 laps in 5 minutes, 6 laps in 10 minutes, 8 laps in 15 minutes, and then 10 laps in 20 minutes. So that's what her rates would look like, or a ratio for her rate. What do you notice about those ratios? Well, maybe you're seeing some patterns possibly. For example, if I look at the bottom number, it increases by 5 each time. If I look at the top, it increases by 2 each time, but notice we're kind of adding there, we're not really multiplying. Can they simplify back down to the 4/5 every time? If we take 6 and 10 and we simplified it, would it go down to 4/5? Well, we would divide them both by 2. That would give us 3/5. Is that the same thing as 4/5? No. What about 8/15? If we divide, there's nothing we can divide both of those numbers by, is there? What about 10/20? What would that simplify to? 1/2. Are any of them simplifying the same? No. So Jenna's ratios there are different. They are not simplifying to the same fraction like Tom's did. Tom's ratios are an example of proportional relationships. All of the ratios simplified to 3/5. Jenna's ratios are examples of non-proportional relationships. The ratios simplify to various amounts. They are not the same when we simplify. That's going to be the biggest piece you're looking for. Do my fractions simplify to the same thing? If they all simplify to the same thing, you have proportional relationships. If they do not all simplify to the same thing, then you are dealing with non-proportional relationships. Let's look at some examples to practice. Do you think this set of ratios is proportional or is it non-proportional? So for the pounds of coffee listed above, the cost in dollars is listed below. Do you think these ratios are proportional or non-proportional? Remember, we're thinking about, do the ratios all simplify to the same thing? I noticed that my starting ratio is 1/3. My next ratio is 2/6. If I were to simplify 2/6, would I get down to 1/3? Yes, I would divide both of those by 2, and that would get me down to 1/3, or 1/3. What about 3/9? Does that simplify to 1/3? Yes, because if I divide them both by 3, I get down to 1/3, 1/3. And my last one, 4/12. Does that simplify to 1/3? Yes, because if I divide both of those numbers by 4, I get down to 1/3. All of the fractions simplified to 1/3. That means we are dealing with a proportional set of ratios here. Each rate can simplify to 1/3. What about this set? Do you think these are proportional or non-proportional? Pause the video if you need more time to think. Well, do all of the fractions or rates simplify down to the starting ratio of 1/6? If you were to simplify 2/14 here and divide both of those by 2 to simplify, what do you get? 1/7. Is that the same thing as 1/6? No. So we can already tell you that this is a non-proportional set. 3/22, I can't even simplify. 4/30, I divide those both by 2, I get down to 2/15. None of those rates are the same, they are not equal, so this is a non-proportional example. Proportional or non-proportional? Time in hours compared to distance in miles. Pause the video for more think time if needed. Hopefully you said non-proportional. These rates do not simplify to the same thing as 1/50 here. 2/70, if I divide those both by 2 to simplify, I get 1/35. That is not the same. 3/90, if I divide by 3 to simplify, is 1/30. That is also not the same. Okay, and if I simplify 410ths, it's also not going to be the same. So we're looking at our rates. If we simplify them, do they all equal that starting rate that we had, or do they all simplify the same? And in this case, they do not, so that's how we know it's non-proportional. Number of spiders to number of legs. Pause the video to decide if this is proportional or non-proportional. All right, you guys, hopefully you said that this set was proportional. Each rate simplified to 1/8. If I divide 2/16 by 2, I get 1/8. 3/24 by 3, I get 1/8. And 4/32 or 32s by 4, and we get 1/8. They all simplify the same, so this is a proportional example. That's all I have for you today. If you have any questions about proportional versus non-proportional, please check in with your teacher.